Well, hello everyone. Welcome back to Adrian's Digital Basement 2. Today we're going to be looking at this television, which you see on the bench here. This is a Sony KV-9PT50, 9-inch Trinitron TV. And as you can see, this is one extremely sad little television. In this video, I want to try to resurrect this TV, well, at least figure out if it's working at all. And if it does, then maybe I'll try to reassemble the TV. I mean, as best as possible when it's like this. Clearly this television has been dropped. There is substantial damage on the front of the case here where the CRT is mounted. The entire chin part, which is what this is, has been broken off. And even on the back cover, which is mostly intact here, but there's all sorts of pieces missing from the plastic. So this entire front corner where the power button was, that plastic is just gone. The PCB though seems to be fully intact, so the power button is right here. Someone had obviously been inside this television. They had harvested the power cord, which would normally attach right here on the PCB, and that's gone. It's a curly, like a kind of a, looks like a keyboard cable, but it's an AC power cord. The rest of what's inside the set looks okay. We'll take a look at that in a second, but someone had removed like the neck board and unplugged some of the connectors in there, maybe trying to see if this thing worked. The thing about Sony Trinitrons is clearly this thing had a big impact, which did all this damage to the case. The shadow mask inside these CRTs is quite fragile to impact and can actually warp and distort from impacts. So while this set may actually work, it may be impossible to get the color purity set up properly on this thing where there's no blobs of the wrong color on the CRT. And that's simply the factor of the bent shadow mask. I was watching the channel 12 Volt Vids where the guy who runs that channel used to be a Sony service tech, and he said that he would get TVs in for service where they had to replace the CRT, and these were large TVs, and Sony would ship a brand new CRT in original Sony packaging from the factory or wherever, distribution center, and it would arrive and the CRT would be damaged. There would be color purity issues that were impossible to dial out using any kind of setup on the screen, and he would have to just call them up and be like, "Another damaged CRT, please send another one." Perhaps the fact that this is only a 9-inch CRT, you can see it's pretty small here, means it's a little bit more resilient to that. I don't know. Now, as I mentioned, I haven't done any testing on this thing at all. I did take a look at the PCB though, just looking for cracks, as I've talked about in previous videos. Whenever you have a CRT that's been dropped, you always got to inspect for cracks. I don't see any damage to this. It was the plastic case, which is somewhat brittle, obviously took the brunt of the impact. Now the front chin here, I have to admit, I did use a little bit of JB Weld on here just to kind of glue it back together, and that's because this whole thing was completely falling apart. And this is actually what holds the PCB in place. So the PCB is just sitting like this because there is nothing holding the PCB on except for this bottom piece, which is missing. So at the minimum, if I do get this thing working and we try to make it, well, go back together, I'm gonna have to either try to JB Weld this bottom piece on, even though with giant missing pieces, and inevitably probably use like gaffer tape, like put the back cover on and then put tape all the way around just to try to hold this case together, because the only thing that holds the PCB in is the back cover here. There's like tracks in here. And then of course, this thing right here has these little notches. Now the crack was pretty substantial, so this whole piece right here was just like completely like loose and flopping around, which just gave no rigidity to this whole thing. It just was not staying together. For testing this thing, I think I'm gonna have to test this in this exact configuration. Now, unfortunately, there's a bunch of tape residue on the side here, which is making it very hard to move around. I should put maybe some Post-it notes under there just to stick that on so it doesn't keep sticking to my bench. Okay, there we go. So now I can at least slide that around a little bit. Okay, so first steps, we're gonna have to reconnect the power cord. So these little wires right here, this is where the power cord went. This is an isolated power supply design. The power switch is right down here. It is still intact. It hasn't broken off or anything. The rest of the PCB looks fine. No components are broken off. Everything looks okay, as I said. So for testing, I just need to make sure this is all sort of propped up in a way that's safe and you know, not touching anything metal. And then also I'm gonna need to clip on a power cord here, plug in any additional connectors that are disconnected, like the neck board is currently off. You can't see that right now. And let's see if it works. Because to be honest, if this thing is dead, there's really no point for me to go much further with it. Here's a look at the side view with the neckboard reattached. You can tell by the lack of soot on here, and in the back cover here, or the rear case, not a lot of soot. That means this is probably a relatively low hour set. There is the speaker bracket that I was talking about. It's kind of holding up the whole set right now. So this is a little tenuous. I do have this little piece of orange adjustment tool there propped up against the speaker and up to here. So it's kind of holding the PCB out of the way. But I think everything is connected. Oh, wait, this is not connected. Okay, that's just a speaker connection. So that is not a big deal. I will connect that up, and I'm gonna go find a power cord to attach to the PCB there, or something I can just clip on with clip leads, I guess, and let's see what happens. All right, I think we're good to go. I have this power cord very sketchily connected. Don't try this at home, anyone. Whoa, that wasn't a good sound. It sort of turned on, it sounded like, and then we heard a high-pitched squealing sound. I just popped the neck board off. Sony sets are pretty good at figuring out that things are wrong, so they, don't destroy themselves, basically. And I need to poke around on here and just see what's going on here. That's definitely on there correctly, so that is not an issue. There is a ground strap that goes from the CRT right here, and I see it goes over to, I don't know, a metal shield around the flyback. There are a couple connections here on the neck board. There is this gray cable, which is also a CRT ground, and I can see that goes to the ground right here. So that's correct. And then there's this red wire, which goes down to the flyback. I am double checking that I had the deflection yoke connected correctly, and it's keyed. So it really only goes on one way. So that is on the correct way. Just saw something that means that there is no hope for this. The CRT is broken on the back here. Hopefully you can see this. The glass is actually cracked. I didn't notice that originally when I was looking at this, kind of giving it an inspection, but I can see a crack that goes right there. And I don't think that's really going to come across in the camera, but it is absolutely cracked. So that means there's air inside this CRT, which means that the high voltage is just going to arc as soon as that comes up. So really, unfortunately, that means that's all she wrote for this set. There is nothing more I could do to try to get this thing working. That CRT is toast. Just pulling my power cord off there. The CRT is toast, and finding a replacement 9-inch CRT, I mean, what are the chances of that? Seems like I wouldn't be surprised if this lower PCB here is actually completely fine, like the flyback transformer, although there's really no way for us to know for sure. And while I know a little bit about CRT swaps with other types of monitors, I don't really know much about Trinitrons and the intercompatibility from one Trinitron TV to another. There were high-resolution 9-inch CRTs used on some computer monitors, oscilloscopes and things like that, but I have a feeling that's not going to be compatible with this one, which surely is like a lower resolution television style CRT versus the high-res thing that would be on one of those computer monitors. So with that very sad and unfortunate news, I might as well take this thing apart down to its constituent parts, and let's take a look at what we find in here. Now I gotta say, this does bum me out that this is actually not working, because I was really hoping to get this working, even though it, it's gonna have a ugly looking case that's all cracked and stuff with tape on it. It still would be really cool to have a set like this. And one of the reasons why is, of course, Trinitron TVs rock. They just have really good picture quality, great color, all that kind of stuff. But the other thing is, I was looking through the service manual and the schematics for this thing, and it doesn't seem like it's that hard to do some RGB mods on this. And I feel like a little 9-inch RGB monitor would be pretty cool. I'd still be able to retain like the composite video input that's already on here. I was also looking at maybe a way to mod S-video onto this thing to allow it to have higher resolution hooked up to something like a Commodore or something. But unfortunately, none of that is going to happen because, like I said, this set is no longer going to ever work again. Okay, so looking at the front of the set, there it is. There's the CRT. Normally, obviously, the controls would be underneath, but those are missing and pieces of plastic are breaking off right now. If we flip this thing like here, obviously we have the speaker assembly. Let's pop that off. There we go, that just came right off. So we have a regular speaker, and of course it's a magnetically shielded one, Sony branded, since Sony makes all of their own parts. That just slides out of the bracket easily enough. Next thing we see here is this wire right here, this white and black wire. Now what this is actually part of the degaussing circuit, and the degaussing circuit is able to basically neutralize some magnetic interference that might be attached to the front of the CRT. This is the connection right here, and it connects up to the PCB. And when the TV is first energized, you'll hear like a brrr noise, a hum, and that is the 60 hertz or 50 hertz, depending on where you live, AC mains getting shunted through this wire. Now it's going to be a little hard until we take the plastic off, but basically the degaussing coil, you can see it right here. See this wire that's running there that's wrapped in black? This runs the entire perimeter of the front of the CRT, and that is where the current runs through that is connected to this wire here. So that is the degaussing coil. Pretty much all color CRTs are going to have a degaussing coil installed around the front perimeter like that. It doesn't always have to be right along the front edge. Sometimes it can be like sitting like back here like this, or maybe the front edge there and kind of loops around the bottom. I don't know the exact science to where it needs to be placed, but Sony seems to be really good and always have it routed right along the top edge. Now you can see with this particular CRT, Sony has this metal structure that's around the CRT, and that's very typical for them. Most other manufacturers don't do that. That is not part of the CRT itself. That's just part of the structure that holds the CRT, probably to reinforce this relatively flimsy plastic, which is why while the plastic broke, the structure that holds the CRT did not. There's the part number of the CRT. It's a Sony A23LDU10X. So 23 centimeters, I think is what that stands for. TVs made in the US back in the old days are gonna have like 9 or 12, like for the number of inches, but pretty much everything, you know, from the 80s on was made overseas, and it's gonna have metric. Now I'm gonna take the 4 screws out that hold the CRT in here so we can get a better look at the, get a better look at that degaussing coil that's underneath this plastic here. Now, normally I would never advise putting the CRT face down like this and dragging it around on your bench, because while glass is very strong and doesn't scratch very easily, if there are little pieces of sand or something on my bench, that could easily scratch the glass. If you watch Jerry rig everything, you know, tempered glass, which is not what this is, I don't think, but you know, light scratches at a number 6 and deeper grooves at a number 7, and that's the Mohs hardness scale. All right, so taking those screws off has released this metal structure here, and this is where the degaussing coil is actually mounted to. So there it is, and it actually looks like, I don't know, there's some kind of a inline resistor maybe or something there, I don't know, but it loops around here. And oh, how interesting. Okay, so Sony only loops it here and up here. It's not even on the left and the right side. I have to say, I've never seen that before. Perhaps that has to do with the way the shadow mask works on a Trinitron. I don't think I've ever dismantled a Trinitron before. I've never had one that was totally broken like this one is. Also on here, you'll notice that these copper fingers are there, and there's this gray wire hanging off. Now this is the CRT ground, and it touches right here, which has this dull appearance. This is the DAG or aqua DAG. Remember that a CRT is a large capacitor effectively. And one of the connections to the capacitor is that's the high voltage connection, which they put a little bit of grease on or something. And the other is on the outside of the glass here on this gray. So this part of it is always connected to ground, which goes back to the neck board and the main PCB. And then the high voltage is always to this connection right here. So these little fingers just ensure that there's a good ground connection to the outside of the glass. Although typically the implosion band, which is this part right here, this metal band, is also grounded, typically, but not always. I don't know, it depends on the CRT. So sometimes you'll see metal fingers like this touching the glass. Other times there's like a metal wire that literally runs across the glass over the DAG part, this dull part, and then that's what's grounded. It just depends on the manufacturer. All right, so that's junk. Let's take this out here. All right, so there's the plastic that is so damaged. Let's see, where's that glued part that I did? I kind of wasted my effort, I guess, didn't I? Gluing this together. But if we kind of fit this back together here, that gives you a rough idea of what this would have looked like. There's a giant hole missing there where the plastic is gone, and then this whole corner was gone. But I feel with some JB weld in there and then some tape eventually, then maybe this would have actually held. Now I am curious, throwing out on the ground, this JB weld, I used the quick weld. How strong is this? Oh, this is strong. Oh, wow. Oh, okay, well, not as strong as the original plastic. It obviously just broke along there. But you can see I didn't get a lot of the epoxy actually in between the plastic. There's a little bit of it there, but not a whole lot. Back to the CRT here. So if you flip this up, there it is. There's that nice front curvature with that awesome cylindrical curvature that the Trinitrons have. And listen to that. That's the shadow mask inside vibrating. Now, back to what I was saying, this band right here is the implosion band. And that's because the CRT is under a vacuum. Well, this one's not anymore, but normally they're under a vacuum. So they're trying to, you know, compress, right? The air pressure out in the atmosphere here is trying to compress them. Now, because the front glass on these types of CRTs is curved, if you try to compress the front glass, what's going to happen? Well, if you have something that's curved, like my hand here, and air pressure is pushing here and pushes up, it actually gets longer. Notice the tips of my finger here get a little further out. Well, this metal band, which is welded on, there's the weld mark right there, and there might be some on the bottom. No, oh yes, there is. There as well. That band provides the extra strength to the front of the CRT that makes it very difficult for this thing to implode on its own. Obviously, if you hit this thing with a hammer or whatever hard enough, it will crack and it will let the air in. But the implosion is dangerous because I think what could happen is if it implodes on its own, then all of that air rushes in really, really quickly to something that's all fractured, and then, you know, pieces can come flying out. This band just ensures that you do not have that kind of explosive compression, I guess you might call it, because it's not decompression because this is under vacuum, but the air rushes into it and then can cause pieces to fly out. I wouldn't mess with the implosion band just because this, you know, is dangerous. It's vacuum filled and this one's not very big, but a large one is, and there's a lot of vacuum in there that the air could rush into and cause an issue. Now let me remove these other two parts here. So this first thing here, which is gonna be stuck on there really well, or maybe it's not gonna wanna come off because of the fact that this glass is actually broken. I'm gonna wear a glove just to be safe here. Okay, it's coming off, there we go. So this thing here that I just took off is the convergence assembly. Now essentially, there are little magnets inside of each one of these little sliders. And there are sliders here. Now they put some glue, that's what this white stuff is here, because this was adjusted at the factory and they don't want you adjusting it. But these parts do all slide around. There are 3 cathodes in here that emit electrons for R, G, and B, right? It's color screen. So these little magnets here affect those in just subtle ways that can help align them all on the front of the glass. Now a black and white CRT only has 1 cathode because it just doesn't have multiple colors, so you don't need this whole assembly here to do this convergence. You just have 2 centering rings that are usually mounted here on the yoke that work similarly. There's little magnets, and then that will have an effect on the overall picture, moving it up, down, left, right. These have a similar effect, but they affect the color beams in different ways, like it can move them up and down, left and right, or maybe just adjust the top part or the bottom part. Now, if we take off the deflection yoke, and it's usually pretty stuck on because of age and there's glue usually on there and stuff, let's slide this off. There is the actual CRT exposed. Now, they always put this tape on here. I think it's just like, I don't know if it's thermal tape or extra insulation just to keep this stuff from moving around over time. But if we peel that tape off and you look at the structures in here, again, this is like a vacuum tube like you would see in an old radio or something like that. And hopefully now you can get a good view of this is being actually broken there. There's a crack right there that runs through the glass. It's relatively thick glass, but obviously there's a limit to how strong that is. And the impact that this TV has suffered sent a crack right from there all the way under the tape there. And actually flipping it around, I can see there's a big crack right there as well. Now on the end here, there's this little black thing here, right here. Oh, huh. Yeah, okay. We could see, okay, well, I'll show that in a second. So this little black thing is just like a little spacer to help keep the pins aligned. It doesn't do too much, but you may notice there's a bunch of glass on here because that actually snapped right off the back of the CRT. You can actually see inside the CRT there. That means that there is no more vacuum in here, which means as soon as you try to turn on the TV, the filament in here, which is like, imagine like a light bulb, it requires a vacuum for it to not burn out instantly. So you're not gonna have a filament that works, and you need the filament to heat up the cathodes, otherwise they're not gonna generate electrons. And I think there's gonna be arcing inside with the high voltage, which is why when I powered this thing up, we just heard a sound, and that was internal arcing inside the CRT. Well, I'm going to try doing something that I've never done, and I'm going to try to take this piece of the glass off that's broken. It's being held on by the tape, essentially. Funny thing is, when I was taking this thing apart, I didn't notice that this was this bad. But here it is. Okay. Now, I can't disassemble this thing anymore because it's all glued together up here. Now, this is multiple parts, right? Like the front glass is attached to this part, you know, and there's actually glue. You can see the glue right here, this white seam. But this is really impossible to take apart without destroying this thing. And I don't feel like cleaning up a bunch of glass. So what we have right here is the actual assembly, which is what's outputting the beams. And I guess you see those 3 holes? I'm assuming that's for RGB. That's where the electrons are emitted. Now, in a typical CRT, they might be arranged in like a triangle configuration as opposed to next to each other like this. Although I think in some CRTs, even non-Trinitrons are going to be next to each other. But all Trinitrons going back to the 60s are next to each other because the shadow mask is aligned with the phosphor in parallel lines. So of course, this is going to work this way. Now, the shadow mask on a Trinitron are these thin wires. And when you look at these beams here that are coming out of here, they're aligned, you know, I can't do it because I don't have enough fingers, but they're basically converging on the front of the screen. So the 2 outside ones are aimed slightly inward and they shoot towards the front of the screen. And when they hit that thin wire, it creates shadows on the various colors so that the beams only hit the correct phosphor. All right, so I just cut away the rest of it by cutting through that blue stuff there, and you can see there's those 3 holes there. I guess that's where the electrons come through. And then I guess down through those holes there, which you're not gonna be able to see on camera very well, are the emitters, the actual cathodes themselves. They're gonna be down in this lower part here, and that's where the heater is. That's that glow when you turn on the CRT, and you can see a little bit of a glow from the end of the tube. That's the heater that heats up the cathodes so that they can properly emit. Now, I think that what this is going to be one of the grids, and this, to be honest, is one of the other grids, probably. And the grids, which are typically like G1, G2, and I think this one is going to be G4, this one that's further out here, because that's going to be for focus. These have the effects of moderating or accelerating the electrons, basically to control the brightness and the focus and things like that. So yeah, this is all, again, very similar to the way any normal vacuum tube works. Those all have grids as well that have the same effect. If you think about a transistor, right, you have the emitter, the collector, and the base. The base is like the part that controls the on and off of the transistor. The grids serve the same function inside a vacuum tube, where the anode and the cathode are where the electrons flow between, and the grid is what you can moderate or stop the flow or start the flow of electrons and control the amount of the electrons. And that's exactly what's happening here in the CRT as well. And it just has a visual representation on the front of the screen because those electrons are converted to light with those phosphors. Now, I can't slide this assembly easily outside of this glass here, even though it's broken. And that's because these pins here are, I think it's hermetically sealed into the glass. And that's, of course, because they need to maintain a vacuum, right? No air can get inside the CRT because as soon as that happens, it's ruined like it is right now. So if corrosion does happen on these pins, it's possible that the corrosion can creep its way into the glass and break that seal. But typically they're very robust because this technology had been developed over a long period of time. Think about how long vacuum tubes were in use for. So by the, I don't know, late 90s when this thing was made probably, or even the early 2000s, they had already figured out pretty well how to make sure that these stay sealed and they don't leak over time. All right, let's move our attention back to the deflection coil here. So this thing is, well, nothing too crazy on this. The bigger CRTs have a lot more going on with extra little coils and things like that, because by the time this TV came out, this has dynamic convergence where the controller, or like the, I don't know, the main master IC that's on this board here, is able to dynamically change the convergence or the signals that are going through this coil. So it has a very precise beam control. It's able to like move the picture up and down and move the corners in and out and adjust pin cushion and stuff like that. That was all done with analog electronics in the old days and little magnets and stuff to try to fix that stuff. But on later CRTs, it was just done in the integrated circuits that are on the board. So this one is relatively simple. There still are a couple little magnets taped in there. You see there's one right there and one like right there. They may not be magnets. They might be like something to kind of block the magnetic field. And usually those are installed at the factory to fix a specific issue with the picture, like any kind of misalignment of the convergence or whatnot. These seem to be installed like opposite each other. Sometimes you'll find little strips attached to the CRT as well, Let's see if we see any on here. We don't see any on here, so there's nothing attached here. You'll see little magnetic strips here, which also have an effect on like the corner alignment, stuff like that. These little pieces here are just rubber bumpers basically, and they just serve the purpose to position the deflection yoke in a specific place on the CRT, because any kind of movement of this, like if you move it back and forth, not just backwards and forwards like this, but even up and down on the CRT actually affects the convergence and the alignment of everything. So in the factory, they put the yoke on here without these little rubber bumpers on here at all. And the technician will move this thing around and get it turned to the exact right position. Well, as right as it can be after like 30 seconds of work, or probably even 10 seconds. They probably they've done it a million times. And then they peel the backing off these and they stick these in place. And that basically wedges this into the exact position that it needs to be in for the best convergence. The problem is if you try to change the CRT out, like you take this off and take the board and move it to a different monitor, well, the CRT itself may have some differences where like these magnets inside here aren't in the right position. Or obviously, you know, how this deflection yoke is installed. Well, this thing is made by a machine, but there's going to be differences from one of these to another. So the adjustment of all this stuff needs to be set up for every single CRT. And when you move this and this assembly here from one monitor to another, or rather one CRT to another, you got to redo it all. And there's a real art to this. I've tried to do that alignment myself, and I've just, it's easy on black and white. There's nothing to really do. But on color, there's a lot of setup instructions, and the service manual does explain it. And CRT techs back in the day who did this for a living, they probably could do it. But I have really struggled, not with a TV because it's low resolution, but on a computer monitor, high resolution like VGA monitor, I've struggled to get the convergence perfect, especially in the corners. There's just an art to it, and I don't fully know it. Now, if for some reason I ever found another 9-inch Sony Trinitron CRT that was compatible with this board, like I had the same voltages and the connector was the same, then I could transfer that PCB, and theoretically we could have a working TV. Of course, that front case is now kind of fallen apart and I broke parts of it, so I'm not gonna do that. And you're definitely gonna have to redo all the setup, which is moving the deflection coil around, like I said, with these little bumpers before it'll be ready to go. Now, just noticed, by the way, there were 3 of these installed around the deflection yoke, and the 4th one, for whatever reason, was just stuck right there at the bottom. Normally all 4 are there. I don't know if they didn't need this one, so they just stuck it there, or is there a reason for that? I don't know. Anyways, so yeah, this CRT, it's got to go to recycling now, especially because it's a little dangerous with this broken off shard at the end. That would be bad to fall on that. Well, let's take a look at the PCB here. So, as I had mentioned, this is the neck board. This is what connects to the CRT. It's got the CRT connector right there. It has the various signals that go into the back to drive the 3 cathodes. That's what these 3 transistors are for here. So that's the RGB drive. There's going to be this high voltage wire here, which is almost certainly, I think, is that going to be the focus voltage? That might be the focus voltage or the grid voltage. I don't know, one or the other. I think it's focus, and basically this wire is pretty high voltage. Not going to be anything like this red wire here, but it's still high voltage, and it makes its way into the connector, and the connector, as opposed to running it through a trace on the back here, it actually runs inside this white connector directly to one of the pins on the CRT. This black thing right here is the flyback transformer, and this is designed to take something like, 100 volts, or maybe, I think this TV's B+, which is the voltage that everything kind of runs at. I think it's 40 volts. It takes the 40 volts that is switched by a transistor, probably this one right here, and that switches it at 15.6 kilohertz, which is the horizontal rate of NTSC, and essentially that generates through windings inside of here, the number of turns, the very high voltage that is required for the CRT. I wouldn't be surprised if this thing is, 18,000 volts, 20,000 volts, something like that. That is running down this red cable here, and it connects to this metal connector here, which goes into the CRT. The flyback transformer, because it is a transformer, transformers always run on AC, it needs to send DC to the monitor. So there's going to be a high voltage diode inside of here that converts that AC into a DC voltage. One of the most common failure modes of a flyback is the windings inside on the high voltage side essentially start to break down, so that when you have that voltage potential of like 20,000 volts, or on a bigger TV it might be 27,000 volts, then you'll get arcing inside the flyback transformer, which will very quickly destroy it. Sometimes you'll see these things like burst because they get hot, like they'll kind of blow up a little bit. It's not like explosive, but you'll see big cracks in it and you'll be able to see inside. That's a sign that the flyback is dead. The rest of this PCB is very highly integrated. So right here, this section has a white line around it. You can tell this is the power supply for the monitor. So the mains AC comes in here. This thing here is what's handling the degaussing, this little box. This thing sends the high voltage to the degaussing coil for like a few seconds and then it cuts it off. Some monitors will have a relay. I don't think this one does. This is like a thermistor. So as it gets hot, it just stops sending the current. It's a switching power supply on this particular monitor because this is a much newer monitor than later stuff. So the monitor is a completely isolated design. This thing is probably generating like 5 volts for the logic circuits on here and the 40 volts for the B+, which goes to the flyback transformer. Any other high voltages that are needed on the set are generated by the flyback transformer actually running. So when you start the set, it starts generating the waveform, which energizes the transformer. And besides this high voltage that comes out of this wire, you also have other windings on these other pins here that run at different voltages that generate like boost voltages that might be like 800 volts, 2000 volts, things like that. So like, yeah, stuff like this G2 connection, which is this thin red wire here. You can see it kind of goes down there on the transformer. It's going to be connecting to one of the windings, and that is also like, you know, fed from that, as is this focus voltage here. It really depends on how the set is designed, on like what exactly is derived from the flyback transformer, and maybe on modern sets it's less and less, but on older sets like the 1702, so much comes off the flyback transformer that when the horizontal is not operating, if you have a horizontal transistor that fails or something in that circuit, then a lot of other things don't work. Maybe even the power LED, the sound, like all sorts of stuff like that runs off of the flyback transformer. When you look at the topology of the rest of this thing, it's relatively easy to understand. This big silver box here is the tuner. So this thing is highly integrated. It uses I2C from microcontroller, like tells it what to do, but it tunes in the RF channel and just outputs a video and audio signal. That goes to pretty much, I'm sure, this little chip right here, and this is the switcher chip. And this switches between the audio video from the tuner and the audio video from the input here. And if you had other inputs on the TV, like other input jacks and stuff, it would go through a more complex chip that has multiple inputs. And sometimes there's outputs. And I think the schematic talks about this set having audio video output, which would be 2 more RCA jacks right there. That would probably take what's on the tuner and actually output it, those 2 jacks, so you can actually hook up another TV or maybe a VCR to the tuner and record that. This large integrated circuit right here, this IC, this is the, I think it's called the Jungle IC, I think pretty much on most sets. And what this does is it takes the video signals, like RGB, composite video, S video, which is like YC, component, all that kind of stuff, and it converts it into the RGB signals that need to go to the neck board right here. This wire right here, it's going to the neck board, and that's driving the cathodes. Somewhere on this set, and probably under this metal can right here, if we look on the back, oh, it also has a metal can. There's gonna be a microcontroller under here. So this is like what's the brains of the television set. And that is what is telling everything else what to do. On a set like this, it runs entirely off I2C. So you can actually hook up an Arduino to this, and if you can figure out what the commands are, you can fully command a television like this, like take control of all the components and potentially switch to different modes and things that aren't normally supported, because the firmware that's on the microcontroller is what generates, or controls all the various features of the TV. Besides the conversion of video to RGB, this Jungle chip on this set, because I looked up the data sheet for this IC, also creates the horizontal drive signature, so that's going to be running the flyback. It handles the vertical, it does all the dynamic convergence, it pretty much does everything. Sony and all the other manufacturers by this point took what was complicated and they reduced it all down to pretty much one IC and one microcontroller. If you eliminate this stuff here, which is like the power supply on the board, and you took away the tuner, I mean, you can look at how little there is on this set. There's this IC, there's the microcontroller, there's the horizontal drive, there's the vertical drive, and the flyback. And that's it. Like everything else is handled by these ICs. Now the microcontroller, which is under this can, like I said, also handles the remote control. So that's the remote sensor on this set. It handles all the buttons, so changing channels, stuff like that. It generates the on-screen displays. It sends those as RGB. On this set, it sends it as digital RGB over to this IC, and that is mixed with the video signal. But it has the capability of like blanking out the video signal. So for instance, if you're on the tuner, and you want to change channels, it blanks the signal while you change channels so you don't see it like get staticky for a second while it tunes in. Now, I talked about RGB. Obviously, I'm not going to RGB mod this because there's no way for me to do it. This particular chip, according to the datasheet, has a digital RGB input and an analog RGB input. The digital input on this set is used from the microcontroller to do the on-screen graphics, and the analog input is not connected to anything. It's just connected to ground over on this side through a small capacitor. So my idea was for RGB input would be to connect up to the analog inputs, which incidentally take the perfect 0 to 0.7 volts, which is what a normal RGB signal is, and then feed the sync signal, composite sync, into the composite video. And there's a couple extra pins on here which tell this IC to switch to the analog RGB input. It can be controlled over I2C, but I think it's being controlled over a pin. So I think if you either give 5 volts or ground that pin, I can't remember which it is, then it should actually switch full time, make the full screen RGB, which should turn this thing into a little 9-inch RGB monitor. I've never actually tried to RGB mod like a more modern set like this. In fact, does this have a date on it? Let's see if we can find a date. Yeah, there's the date, November 1997. So I don't think I've ever RGB modded something that was as like new as this set. Obviously, the later you go with sets, the more and more highly integrated it gets. I think they got to a point where the one jungle IC literally does everything. Like the microcontroller's in there, everything is in there. And that means that it's harder to do mods on those because you can't just inject an RGB signal into them because the on-screen displays are already generated inside of the chip. That's a common tactic, is to inject the RGB to where the normal microcontroller sends its RGB signals into the chip, because a lot of times that is analog, not digital like this one. Now, when I looked at a lot of data sheets for these chips, even in North America here, NTSC markets, where SCART's not a thing, RGB is not normally on a set in any NTSC market, even in Japan, which is also NTSC. But it seems like these chips seem to have provisions for RGB inputs. Problem is, if it doesn't have an external line to tell it to activate that RGB signal, they can be really hard to use because you need I2C to tell it to switch to that input. And only if you have a data sheet that tells you what all the commands are, can you even do that. But worse is that the microcontroller, typically on a lot of TVs, is constantly sending commands to this chip to basically take control of it. And I've done some experimentation, and incidentally, on this set right here, this little connector right here, that's the I2C input. You could just connect up to this very easily and try to send commands to this thing. Now, this never worked for me. Obviously, I could never test it, but other TVs I've connected up to an Arduino to send commands to, I found that I could do stuff, and then after a moment, most of those commands would immediately be overwritten by the microcontroller. Almost like every second, it was sending like a fresh set of commands to this IC. Maybe that's because it could glitch, and they were concerned if it glitched in a bad way, that could like cause damage to the CRT because it might change the refresh rates or I don't know, whatever. So it just sends fresh set of commands constantly. Not every command on this one set I worked on did that, but definitely it made it impossible for me to try to like switch to a different mode because it would just constantly revert back to the setting that the microcontroller was doing. And I wouldn't even want to disable the communication from the microcontroller to the chip because there's some like beam current regulation and stuff going on, like some feedback stuff with the way the whole analog part, the high voltage part of the CRT is working. So I don't even know if it'd be a good idea to take that away because I think these chips are designed for that two-way communication with a microcontroller. It varies widely from one set to another. There are many, many different ICs that do this type of jungle, and only some have data sheets that are even released so you can know what the commands are. This particular chip on here, which I forgot the name of it is documented, and it does have a data sheet that you can download freely, so you can see all the commands this thing does have, and it's got all sorts of stuff in there. Anyhow, that's about it for this Sony CRT. It's really sad that this thing is basically toast, and unfortunately, this thing is never gonna work again. And you know, if there was some kind of likelihood that someone had a good CRT that had a bad board, I suppose I could try to use this board. But almost certainly, if one of these TVs was ever used to death, where like something were to fail on it, it's gonna be the CRT that's gonna fail either from an impact, like what happened here, or it's gonna be worn out with a dim picture just because it was overused. Although I tend to think that the smaller the CRT, the less use it gets because it's like an occasional use in the kitchen or in a bedroom, not hours and hours and hours a day like a big living room TV. It's a real shame that this thing was destroyed because I feel that this thing was low hour and would have worked really well. But such is life when you're small and portable like this. It probably just got dropped, and that was that. So that's gonna be it. If you found this video about the anatomy of a Sony CRT interesting, I'd appreciate a thumbs up. But if you didn't, you know what to do. Thanks to my patrons. Their names are scrolling up, I don't know, this side of the screen or maybe this side of the screen today. I mix it up depending on the video. Patrons get early access to videos, stuff like that. And yeah, you know, comment down below. I'd love to hear what your thoughts are on this video. I mean, again, I'm really sad. I would have loved this thing to work. Even taped up and broken, it would have been fun to have a little CRT like this, a little Sony CRT to experiment on. Thank you very much for watching. Stay healthy, stay safe, and I will see you next time. Bye. It's like etch and sketch for CRT.